Hello again, everybody. I'm Luca Balzani from Audison, live from Electromedia showroom.
And I'm Ken Ward from Portland.
And we're here for part 4 of our exploration through OEM integration. Today, our topic is Forza, power and flexibility. This is our 4th episode, and we're very happy to say that episode 3 had the most attendees so far. This needs to be celebrated, and I would like to make a toast, naturally, with the good glass of Italian wine to the hundreds of followers we had so far, and another toast for the many that will follow. Ken, do you have a glass of red for toasting?
Luca, it's 10 in the morning over here. All I have is coffee.
Okay, never mind. Raise your mug and to the health of our attendees. Salute!
Salud.
Now, time to get back to work. To understand the Forza, you need to know the history of Prima bit amplifiers, I believe. And Prima AP bit amplifier series, the first Audison amplifiers with DSP built in. These amplifiers were in all new category for Audison, including an 8-channel amplifier that was a breakthrough product. 8 bridgeable channels adds flexibility and allows open system design. One frequent request from specialist dealers was to models with even more power. And that's the origin of the APF 8.9 bit, taking the Prima DSP amplifier concept and upgrading it for higher performance systems. But let's first review the Prima family features. Prima has a 4, 5, and 8 output model with bridgeable channels, and this is a very important advantage. It gives especially great flexibility in configuring different systems.
It might seem obvious to some of you because
Right.
Audison amplifiers have always been bridgeable, but most of the amplifiers that are on the market in this category are actually not bridgeable. So if you have a AP 8.9 bit 8-channel amplifier, you could use it as a 7-channel, a 6-channel, a 4-channel, or a 5-channel. And we're going to talk more about 5-channel configurations later on. But if the 8-channel you have isn't bridgeable, you don't have that kind of flexibility.
And don't forget, Audison AP bit amplifiers are also 2-ohm capable. Now, every model has 6 OEM compatible inputs. Now, since this is an OEM integration thing, can you tell us about more Prima input management?
Yeah, I'd be happy to. So you mentioned that the 8.9 bit has 6 input channels. Each of those channels can handle up to 22 volts of signal. Now, there are 9 different predefined configurations that you can use those inputs in. And the input configurations describe the OEM system and the signals we're using from the OEM system. They don't necessarily describe the system we're installing on the output side. We define that later on in the software process. But the most common setup is the one you see here, front and rear. In this configuration, the front and the rear channels are handled independently and they're not summed together, so the factory fader would still work. And when you use this configuration, you get to decide, you can see down at the lower right, you have to decide, do you want the subwoofer signal to come from the front channels, the rear channels, or sum them both together into a non-fading bass situation? Now, this is one of those questions that you will not know how to answer properly if you haven't tested the wires to know which signals have the sub bass in them. Now, the next configuration is a 2-way front plus rear. And in this scenario, there's a front high and a front low. And the bit is going to sum those channels back together to as close to full range as it can get, and then DEQ them back to flat. And since there's no subwoofer input, once more, we have to choose which input channels the sub bass is going to come from, the front, the rear, or both summed together. Now, this configuration is front and rear and left and right stereo subwoofers. And the front and the rear get passed through and the sub gets passed through. And the same thing happens in this configuration, but it's a mono sub. So there's only one subwoofer input. This is a pretty common configuration out there in factory systems. Now, this one has front channels, rear channels, a center channel, and a mono sub channel. And each of these is kept isolated from the others all the way through. There's no summing at all. And you might remember back in episode 2, we talked about different cars that you could use this configuration with when there is a factory up mixer present. So this one here is just 2-way front, high and low, and the bit will sum them back together and then DEQ them. And here is two-way front with stereo subwoofers. The front high and front low get summed together. The subs will get passed through. And then the same thing with a mono subwoofer. So there's a list of 9 different configurations, and you just have to select which one you want, and you're done there.
Yeah, remember each configuration has both DEQ and automated summing for OEM signals. Let me point out that this is the only DSP amplifier on the market with this capability. 8 DSP channels plus a 9 channel for an active subwoofer or to drive an external monoblock. The Toslink SPDIF input is compatible with digital output Toslink head units, the BDMI digital preamp, or the CTO high resolution converter. Optional DRC remote control support, which, as we discussed in episode 1, give us master volume control, subwoofer level control, and preset access. Let's see, then the Prima DSP equalizer uses a proprietary technology, which I like to call algorithm control equalization.
Algorithm controlled equalization. Let's call it ACE.
Wow, I like ACE, and I think it's a great name. So ACE uses parametric technology, but with simpler controls. This is a great list of functions, but can you tell us more about how ACE works, Ken? Before we can explain how ACE works, maybe we should explain a bit how equalizers are in general working.
Yeah, that's a good idea. So let's assume for a moment that we want to get the signal back to flat. Now, in cars, when I tune a car, I do not tune it for a flat response. But let's use a flat response in our example for simplicity. So what we're trying to do is make all of the different notes equal in amplitude.
And is that why it's called an equalizer?
Yes, that is why they call it an equalizer. And what equalizers do is they add or subtract gain at certain frequencies. So here's a graphic equalizer, and this is what comes in the original bit 1 and also the bit 10 and also the Hertz H8. They all have 1/3 octave graphic equalizers. The Prima products, the BitNove and the Virtuoso use parametric technology. So I'm going to use some screenshots from the Virtuoso to explain the difference. Whenever a product designer is defining an equalization curve, they have to decide on 3 things. And the first one is, what center frequency are we going to affect? And in this chart, you can see that the center frequency is 350 hertz. And at the bottom of the screen, there's a circle showing you the 350 hertz. The second question that you have to decide is how many adjacent frequencies immediately above or immediately below 350 hertz are we also going to affect? And in this chart, you can see it's kind of a moderate effect on those adjacent frequencies. Now, if you look at the bottom of the screen, you can see that it says 4.4 in the Q window, and Q means band width. So the lower the Q number in that window, the more adjacent frequencies are affected. And I put 4.4 here in our example because that's the standard bandwidth for 1/3 octave graphic equalizers. So this is what we would get with a bit 1 or a bit 10 or an H8. So the third question is, how much boost or how much attenuation are we going to apply? And in this example, you can see the circle at the bottom of the page tells us that we have boosted by 12 dB. Now, wow. 12 dB would be like 16 times the amount of power you were originally getting at 350 hertz. So I sure hope we know what we're doing in this example.
Hope so.
So with a graphic equalizer, the product designer has permanently answered those first 2 questions for us. The frequency that's going to be affected and the adjacent frequencies that are going to be affected have been permanently defined. The last question, how much boost or how much cut are we going to add, is the only thing that the user of the equalizer in the field gets to decide. We basically get to decide how far we're going to move that slider up or down. So once you think about it that way, tuning a 1/3 octave graphic equalizer, if you have a 1/3 octave analyzer, is pretty simple. And let me show you what I mean by that. Now, in this picture, the RTA on the top has 30 bars. And the BitTune RTA doesn't have a bar at 20 hertz. It doesn't try to measure 20 hertz. Now, the bit 1 equalizer that's at the bottom of the screen does have a slider for 20 hertz. So if we scale these two pictures so that the 20 hertz slider is off to the left, we now have a 1-to-1 relationship starting at 25 hertz all the way up to 20K. So the idea is, if you want a bar to get shorter or taller, you move the slider up or down. It's a 1-to-1 relationship. So it's not very abstract. Now, if we look at parametric for a moment, you see here that the Q is 4.4. That's all we can get out of a graphic equalizer as a general rule. We can't change it. Now, what if we changed it to 1? You can see the curve got a lot wider, and we're now affecting a lot of adjacent frequencies. What if we changed it to 6? Now we've made it much narrower, and we're affecting much fewer adjacent frequencies. So I'm going to show you a different example. Let's say that we measured the sound in a car, and we got this response, and there are 3 big deviations from flat. There's a wide peak at 65. There's a wide dip at 250. There's a narrow peak at 2K. Now, note that they all have different widths. So what I'm going to do is take this curve and I'm going to flip it upside down for a moment, because our goal is to make everything equal. And this is how we would make everything flat, is by tuning our equalizer to this upside down curve. If we can match this inverted curve, we can get a flat line. So here is what we can do with the bit 1 equalizer, with a graphic equalizer. And you can see it kind of works. But we've used 3 bands, and we've used them all at the proper frequencies, and we've added the right amount of positive or negative gain, but we haven't really addressed the problems completely. To get closer, we would have to use more than 3 bands. And if you look at this picture here, you can see we didn't really nail it. Now, let's try it with parametric bands. You can see here, parametric fills the gap much better. We've matched that inverted upside down curve very closely. And when we flip it right side up again, you can see we're going to reverse that curve really, really well. And we did that with 3 bands, which meant we had to make 9 adjustments, because each parametric band asks us 3 adjustments to make. So that's the parametric from a virtuoso. What about if we were using a Prima? So I'm going to take our measurement and I stretched it vertically a little bit. And I did that because the Prima equalizer display has a taller vertical scale. So I wanted to compensate for that. So let's take this line, turn it upside down, and lay a Prima equalizer on top of it. So you can see that once more, we have matched that curve with 3 control points and 9 adjustments by changing and using different cues. So there we go.
Yeah. So with the parametric EQ, you're saying all 3 decisions on configuring an EQ band are made by the user. And this makes the parametric EQs much more powerful, right? And actually, it also makes parametric EQs a bit more work to use, because each band requires the user to make 3 decisions instead of just 1. Parametric EQ is a very flexible tool. It lets us do things that might not be the best thing to do, like boosting at 1 note and attenuation and another note when those notes are very, very close together.
So when there's any large change in amplitude, as a rule, there's a large change in phase as well. And so whenever we're equalizing a system, we cause phase changes when we make amplitude changes. But if you get large changes in phase, those can cause audible cancellations. And if we put 2 EQ bands too close to each other, and one is boosting and one is attenuating, the phase result can be poor.
So what would be the best way to use a Prima EQ?
Well, let me put this up here. The first thing that you need to do when you're going to adjust an equalizer is you need to measure the response. And so the technician needs to have some kind of acoustic performance measurement tool. And here we're going to use the RTA function of the bit tune to decide what changes are required. And I'm going to turn this upside down again so that we can see the inverse. Now, I'm going to take the Prima EQ curve and put it upside down there and follow that inverted curve. And you can see that I did it here with 6 control points. And that means that I had to make 18 adjustments. And that might seem like a lot, But I did the same exercise with a graphic equalizer, and I had to use 28 bands to get close. That was almost every band I had.
Yeah.
Now, while you're doing this, the ACE software routine runs in the background, and every equalizer uses digital biquad filters. Every DSP equalizer uses digital biquad filters to change the sound. And ACE decides how many to use to give you what you're asking for, while introducing the minimum possible phase shift. So parametric equalizers seem like more work than graphic equalizers, but I believe they're a lot better at helping us tune cars more quickly once we understand how they really work. Now, one example of ACE is right here. I've tried to take the control points and move them together really closely. And ACE does something here that traditional parametric equalizers can't do. You see how the peak and the dip are not on top of the dots anymore. And this is because I asked for those two to be on top of each other so closely that ACE overruled me and didn't allow them to get that close. Now, it took a lot more development to do this algorithm than standard parametric equalization controls, because those assume familiarity with parametric equalization and the right way to use it. So here's a pretty standard wide center frequency that you couldn't do with a graphic equalizer. Now, here is where we have two filters, and I've moved them fairly close together, and you can see that the peak doesn't follow the dot. Once again, that's ACE keeping us out of trouble.
So the algorithm control equalization keeps you out of trouble, as you say, and even if you are not a parametric expert. And this by simplifying the process and acting as a guardrail. You can't accidentally ruin the phase at a certain note by putting two bands too close to each other. And this relates to the final sound quality result that remains the main priority for Audison R&D team.
So a few years ago, you guys made a change to the software, and you can see in the lower right corner, the center frequency and the gain and the bandwidth were all added on the display in the Prima software. And if I blow this up for a minute, you can see the gain is on the left, and then the center frequency is in the center.
Where it should be.
And in the bandwidth on the right, instead of being a Q value, what they're telling us is the lowest note and highest note that filter is affecting.
Yeah, okay. That is a full explanation of the Prima concept. And Forza was born from these ideas, improved in the way we're going to show you today. But before starting with the Forza insights, let me show you a quick video on this great product line. I love this video. I think it defines very well the character of the Forza line. Anyway, going back to showing you the product range, and let me tell you, the dealers told us that they love the Prima concept, but they wanted in a more powerful amplifier, and that was the beginning of the Forza project. Over twice as much power, 85 watts per channel into 4 ohms. The AP bit is 35, by the way. 260 when 2 channels are bridged into 4 ohms. The DSP section was upgraded to bit knob specifications, more Q values. USS speakers loading is built into Forza now. 2 more input configuration, which are 2-way front plus center plus subs and active 3-way front. Now there's full range option in the crossover, And there is even a limiter feature if you have a customer who needs an upper limit on amplifier power to avoid clipping. Some bandwidth settings, such as this narrow Q setting, are now available in the standard Prima bit amplifier, but now, yes, in Forza.
You guys made a lot of upgrades when you went to Forza from Prima.
Yeah, I can tell.
You can see here in the Forza software, we still have algorithm controlled equalization working for us. And one of the things it does is it has kept those dots from being on top of each other. It's kept the filters the proper distance. So even though we put them really close together, ACE kept us out of trouble. Now, there are some things that did not carry over from Prima to Forza. One of them is the input connector pre-outs, because high level and low level are no longer combined. That means if you're plugging a Forza into one of the harnesses in the Prima program, you need to get an adapter from Forza to Prima, which is available. The ASP port is gone because now USS Universal Speaker Simulator loading is built in completely. And the external dimensions, it did get a little bit bigger than the Prima amplifiers. It's a little bit longer, a little bit wider, and a little bit taller. It's still a small amplifier, but this means that the Prima tower kit doesn't fit anymore. So you don't want to try to use the Prima tower kit on a Forza amplifier. You can't use the OEM power wire anymore in a harness that plugs into the head unit. The Prima amps had an adjustable current draw where you could do that in certain situations. But when you're installing a Forza, because of the greater power requirement, you need to do a full B+ run to the battery.
Okay, that makes sense with so much power involved. That was a lot of improvements, and I agree with you. But at some certain point, we realized that there was one big problem.
Oh, what's that?
Prima speakers were designed for use with medium power Prima amplifiers. Efficiency was a crucial factor in designing the Prima speakers, drivers, and crossover filters.
So there wasn't an Audison speaker that was optimized for Forza.
Yes, yes. But there is now. Please meet the Ep.4 sorry, guys. Dealers have told us that Ep6.5 mid-woofer fits in almost any car. So the Ep65P mid-woofer has a similar frame as the Ep6.5. That maintains Prima fitment as much as possible. Luckily, it is a deeper speaker, it has a thicker top plate and a thicker black plate. The magnet itself is slightly deeper. And all of this results in a longer magnetic gap and no longer excursion motor. That required a high roll surround to accommodate the added excursion. So that's the 165mm woofer. Now let's talk about the 28mm tweeter. Has also the tweeter changed so much, Ken?
Well, I think it has. But it does still retain the low profile chamberless design that was in the AP1 that still continues on.
That's
and
good.
As you know, Luca, Electromedia makes a lot of tweeters that have a rear chamber internal that affect the resonance characteristics of the tweeter. But the engineers explained to me they didn't use one of those on the AP1P because the chamber would be too deep to fit in some of the OEM locations that the spec called for it to fit into. They did use a larger dome. It's a 28mm dome compared to the AP1, and that gives us higher output. And you can see in this cutaway, there's more damping material underneath the dome than there is in the AP1. They changed some things in the motor to give us better high frequency response compared to the AP1. You'll definitely notice better sound in the upper octave in the treble. Now, when you go to install it, there's an any install faceplate kit in the box. And this speeds up the installation and it makes it easier to match the interior cosmetics if you're going to see the tweeter. And this thing has backloading parts and flush mounting parts and surface mounting parts and waveguide rings. There are mesh grills and open bar grills. And I think it's everything an installer would want to put a tweeter in a car.
Yes, right. Correct. And let me tell you that after we upgraded the woofer and the tweeter, we have turned our attention naturally to the crossover filters. And the tweeter high pass now is a 12 dB octave second order filter. It's a little higher than the AP1 crossover filter, so we can have higher power handling. There's a woofer low pass to limit the high frequency output from this component, to limit the transition band. And the filters are split into two small modules, which are easier to install. Since they are split, you can avoid new door wiring for dash or A-pillar mounted tweeters. Passive crossover aren't usually a feature, but these are definitely upgraded for the higher power applications. And now, after having shared the new components, we have people here very curious about the 5-channel Forza application you were mentioning. Can you confirm it is possible to use an 8-channel Forza into a 5-channel mode?
Sure. Let me put this slide up here and I'll show you how. So the first part is fairly straightforward. You run the first 4 channels to the cabin speakers and you have 85 watts RMS by 4 channels. Now, the way that we do that normally in North America is we set it up front and rear. That's the most popular configuration for a 5-channel amp in North America. Correct. Of course, I have to be different. So I set it up with a front high and a front bandpass, and I set it up as an active configuration. And you can do that as well. That's my favorite way to use 5-channel amps. So if you see here, we've taken half of the Forza and we've used it on the front speakers and the rear speakers, if we have those. And that's 4 of the 5 channels that we're talking about. Now we have 520 watts available to use for our sub bass. And here's how we're going to do that. We're going to take 5 and 6 and 7 and 8 and bridge them both together. And we can connect that to an APS-10D subwoofer, which has 2 4-ohm voice coils. We could also use an APS-10DS, and that is the same subwoofer driver inside a sealed enclosure, which has both voice coil terminals available on the connections. Now here's the diagram for a system that works that way, where you're bringing out 5 and 6 and 7 and 8 to the same driver. And when you wire it, here's how the wiring looks. Channels 1 through 4 go to the cabin speakers, and then 5 and 6 go to voice coil number 1, and then 7 and 8 go to voice coil number 2. Now, that's a single subwoofer arrangement. We can also do dual subwoofer setups. Here, we're using 2 APS-8Rs, and that is a 4-ohm single voice coil subwoofer. That's an 8-inch. We could also use 2 APS-10 S4S subwoofers. I particularly like this setup. And in this diagram, what we would be doing is taking channels 5 and 6 to one subwoofer and channels 7 and 8 to another subwoofer. And in the wiring diagram, you can see here, 5 and 6 bridge to a single driver, 7 and 8 bridge to a single driver. So there we go.
Now you tested this out recently, right?
Yes, I did. First, I worked on a friend's Volkswagen Tiguan, and I was using these Forza products.
And what can you tell us about that installation?
Well, this is a 2017, and the first generation Tiguan was sold in the US through 2017, even though they had introduced the second generation. So they're 2 cars that are the same year. A friend of mine bought one of these and we made it into an audio project. You can see it had this base model system with the base head unit. It's called an MIB2 entry. It actually has the quad lock connectors on the back and not on the CD player in the glove box. But the standard Volkswagen ISO connectors that are in the Prima program did fit this radio. Now in the door, you can see it's got a pretty standard Volkswagen woofer in the bottom of the door, and then it has a tweeter at the top of the door. Both of those were driven by one deck power channel, and there's no OEM amplifier in the car. We did listening tests to it and determined they were just using basic stereo. So the system that we decided to go with was a Forza amplifier, 165p components, and an APS-10D in a vehicle-specific enclosure. So here's the system design. It's a fully active 3-way setup, 85 by 4, 520 by 1. Now, when we configured the inputs, I set it up to just pull front, and the idea here was that we actually bridged the rear through the harness so that they stayed connected directly to the radio. Now, here's the crossovers we used. We had 3000 hertz for the tweeter and up using 24 dB per octave. Then we used 3000 to 80 for the midwoofer at 24 dB per octave. And then the subwoofer, we played 80 and down. And the subwoofer actually went back here. You can see underneath the load floor, there's a spare tire and there's a big styrofoam pocket to the right of the spare tire. And we got this enclosure from our friends at SRQ in Florida. And when you put this this in, you can see how it wraps right around the spare. And this sped up the installation a great deal. Now here is the Volkswagen speaker that we drilled out of the door. I think in the last episode, we saw you drilling out the speakers out of a different Volkswagen, right?
From a Gold 7 door, right?
Right. So here's why. You can see there's not a very big magnet on there, but the speaker still has a really deep spacer. Wow. And so the magnet is, they're trying to keep the magnet from hitting the window that's right behind the speaker. So what we did is we made a matching spacer that brought that 165 millimeter midwoofer out, and it also stiffens up the door. And we used a Volkswagen speaker wiring adapter to plug it into the factory wiring here. And then you can see there's a shoulder around the outer edge of the speaker. We put a gasket on the back of the door panel so that when the door panel goes back on, it seals up around the speaker. Now on the tweeter, unlike BMWs and Mercedes, Volkswagen didn't snap these tweeters in. They actually glued these in with a heat welding. So we had to carefully cut them out. So to put in new tweeters, what I did was I used parts out of the install faceplate kit. And first I snapped on this waveguide ring that's in the box. You can see it on the right, it's on the tweeter. And then I took this part that's in the box that you guys call a watch band that's for backloading, and I cut the tabs off of it and just kept the cylinder. You can see in the picture on the right, the cylinder is on the tweeter, and that made it fit in the factory location perfectly. And I didn't have to make any parts to do that. Now, here's the amplifier. We made a metal bracket that goes underneath one seat, and then you can see the Forza fits underneath that seat on top of the carpet just perfectly. And it's hard to believe that that has 85x4 and 520 watts for our subwoofer. So the speaker loading from USS worked perfectly. We didn't have any muting problems with the Volkswagen. And we also tested the signal coming out of that Volkswagen. It had 6 volts of DC offset. So the DC signal sensing in the Forza worked perfectly. Amplifier turned on and off like it was supposed to.
So here we go. This is the 5-channel mode we were talking about. 860 watts, and that's a lot of power from such a compact device. But how did it sound?
I thought the system sounded amazing. I really like the 165P speaker set. The better highs are great. The bass from that door woofer is great. It blended really well with the sub bass from the 10 in the back. And my friend who owns the car was really surprised at how good we got it to sound, because he'd never had a high performance sound system in a car before.
Now, how long did it take to install?
Well, since the enclosure was already made, that did speed up the installation a lot. We finished the physical installation in just one day, but it was kind of a long day because we had to run new wires into the door to make the tweeters active. Next time I book it, I would book it for 2 days because we did have to tune the system on the next day.
And that's a good idea, Ken. Take your time next time. Anyway, didn't you also work on a truck lately?
Yeah, we also worked on a Forza system in a 2016 GMC Sierra pickup. And this had Bose. We just did this truck last week. And this platform is also sold in North America as the Chevy Silverado. And it has the same Bose audio system in the Silverado as in the Sierra. So we talked about this in episode 2 about doing listening tests on these cars. So it doesn't have a center channel speaker. And I went ahead and did the listening tests, and I used the Educar Test Tone smartphone app to do this. And if I played a center treble tone and I sat in the driver's seat, it was roughly in the center. It was a little bit off center toward me, toward the near side. And when I played mid-range, same thing, it was a little closer to me. When I played mid-bass, it was also a little bit closer to me. So then I got out and I walked around and I got on the passenger side. And from the passenger side, the treble was pretty much in the middle. The mid-range was pretty much in the middle. And the mid-bass was pretty much in the middle. So this is a pretty good 2-seat presentation for a car that doesn't have an up mixer in it. I would have biased it a little bit to the right so that the driver got a little bit better centered presentation, but this is pretty good. So we pulled the wiring diagram for the car, and this is what we figured out we had. We had a 7-channel amplifier that was connected to a most 50 network. And that amplifier was powering dash wideband speakers left and right. And then separate channels were powering the 6x9s in the door left and right. There were rear door speakers and a tiny subwoofer in the center console. We could barely hear that subwoofer. We had to use a test tone to actually notice it was there. And apparently not all GM trucks have that subwoofer. So now that we knew what we were working with, we took the rear seat out of the truck, and you can see here the Bose amplifier is on the back wall underneath the soundproofing. And we tested the signals coming out of the 7-channel amp. So here is the signal coming out for the dash speakers. And you can see they've boosted the treble a little bit because those widebanders don't play treble quite as well as a true tweeter. And you can see there's no bass at all. It disappears below 250 hertz. So here is the door woofer. And you can see the door woofer is not playing above 4K. There's no treble there at all. And you also notice there's a good amount of overlapping here. So I summed these two signals together as a test. And when I did, you can see, I think the signal should have gotten louder, or the measurement should have changed more when we summed it together. And let me show you what I mean. On the left is the woofer signal overlaid on top of the tweeter signal. And you see the darker bars in the center, that's where they overlap. And the area where they overlap should have gotten a lot louder when I summed it together. But you can see over here on the right, they actually got quieter in a couple of areas. And the reason they got quieter is because we know they're not in phase with each other at all frequencies. So they may not be 180 degrees out of phase with each other because the cancellation didn't disappear off the screen, but they're not at 0 dBs matching either. So I did a similar test on the left and the right door woofer. So this is the left 6x9. This is the right 6x9. You can see they're almost identical. Now watch what happens when I add them together. It ought to just get 6 dB taller, right? But instead, we had two big cancellations appear. We had one at 250 and one above 1K. So we know there's two-seat processing going on here to change the phase to make it sound the way it sounded in our testing. So what do? You could use an external preamp and grab the unprocessed signal right off of the most 50 network. Now, that does add a little bit of cost to the system, but the problem in this case is that we lose the two-seat phase processing that the Bose amp is doing for us. So here's what we decided to do. We decided to retain that two-seat processing. We left the rear speakers stock on the Bose amplifier. We used the Forza 8.9 amplifier, and we upgraded the dash speakers to AP2s. We upgraded the door speakers to AP690s. We used an APS 10D 10-inch subwoofer in a vehicle-specific enclosure. Now, when we wired this, here's what we did differently. We took the dash channels from the Bose amp, ran them into inputs 1 and 2 on the Forza, and configured those as front channels. We took the door woofer channels, ran them into inputs 3 and 4 on the Forza, configured them as rear channels. And then we took the subwoofer channel and ran it into both 5 and 6. And when we set up the software, we configured it in mode 3, front plus rear plus sub. Even though we're not upgrading rear speakers, we told it we were. And we used this mode so that we could use the Forza to not sum the dash and the door together, because it thinks the dash are the front speakers and it thinks the front doors are the rear speakers. So in this configuration, we are avoiding summing the channels together, and we're avoiding any of those cancellations that we tested. So after we did this, we did not perform de-equalization. We're trying to keep the same factory crossover points that are in the Bose amp. So we just passed the signal right through. We clicked on skip when we got to that point. By the way, the Bose amp doesn't clip at 8.8 volts. It had plenty of clean signal.
Wow. Why? I just love this clever and creative way to configure the software.
Well, it works really well. This diagram here might look familiar.
Yeah, it is.
That's the 5-channel mode again. Yeah. And so here's what we did. We took the back half of the amplifier to a dual voice coil sub. I really believe that when you get used to this 5-channel concept, it is very useful in the retail floor. 85 by 4, 520 by 1. That's a really, really competitive power package in a very small enclosure. It's got DEQ and summing, which is very rare for DSP amps. You've got the configuration wizard, so it's simpler to set up. And you've got output tuning, including algorithm controlled equalization. So I think this is a really good package. Here are a couple more installation details about the job that I think some of you guys like this sort of thing. You can see that the floor of the truck underneath the rear seat is not flat. So we built a bracket that bolts the factory bolt holes that holds the amplifier out of the way. Now, on the left is the factory Bose 6x9. And once again, you can see there's a really deep spacer built into it. So we built this spacer in the middle that bolts to the door, and then we put the Forza, the AP690 speaker into it and put a gasket on the front so that it'll seal up to the back of the door. Now, same thing in the dash. We have the Bose speaker on the left, and you can see it's a paper speaker with a tiny voice coil. We built a spacer in the middle and installed an AP2, which is an aluminum speaker with a much bigger voice coil. And here is the subwoofer enclosure. Once again, we got this from our friends at SRQ Customs in Florida.
Nice.
That goes underneath the back seat. And when we tuned it, I went ahead and tested 3 different configurations. The first one I tested was straight pass-through, no DSP tuning at all. The second one I tested was using EQ only. And then the third one I tested was 1-seat stereo for just the driver. And the first 2 configurations, I have to confess, those were not my idea. The theory behind them belongs to a friend of mine. And then I've had other friends who have confirmed them already in the field, that they've confirmed they work. I just never had done it myself. And I really wanted to see for myself how it worked, because I thought I could explain it better. So the first one was straight pass-through. This was very similar to taking a normal non-DSP 5-channel amp and running the dash signal into inputs 1 and 2 for the front, and running the door signal into 3 and 4 as if they were rears, and then running the sub into channel 5. But then we have to use OEM speaker sizes like the AP2.
Why OEM speaker sizes?
Well, we're going to use the OEM crossover points. We're not going to use the crossovers in the amp. And so this trick can only be done if you have wideband dash speakers like the AP2. You don't want to use the amplifier crossovers because they change the phase of the signal. So you're just going to adjust for level with the input sensitivity knobs. You turn down the front speakers a little bit to match the door woofers. So when we did this, the sound was really good tonally. The imaging was just as good as it had been in my original testing. We didn't screw that up. I did bump the head unit balance control 2 clicks to the right so I could get my centered image right in the center of the windshield, and it worked great.
This means you can do the same thing in these tracks with an SR5600 and no need of bit processor at all?
Exactly. In this particular example, using the right speakers is the OEM integration technique. Now, I know this is the Forza episode, so I apologize, but I thought this would be useful to mention.
Yeah.
The SR 5.600 has speaker level inputs and it has USS built in. So I think it's perfect for this kind of upgrade. So then we did test number 2. Now, we knew we still wanted to retain the 2-seat nature of the system. So the way that I EQ'd it is I put the mic for the RTA in the driver's seat, but I kept left and right in the equalizer tied together. So any changes I made to the system would affect both sides equally. And I was able to improve the sound tonally over the pass-through mode without damaging the 2-seat presentation. And it sounded even better. So the third test, I tested a 1-seat tune.
I thought the OEM phase equalization prevented a 1-seat tune.
Well, that's a good point. And so let me try to put it this way. It prevents us from using delay in getting a 1-seat tune. But think about it this way. When we use delay, we're using it to correct phase cancellations at the driver's listening position, right? Now, Bose did it a different way. They used phase processing to accomplish the same thing. And they didn't do it at every single frequency, but they did it at a lot of frequencies. So when we tune, we're trying to solve the 3 problems of car stereo. What if we just ignore the 3rd problem of car stereo for a minute? What if we set the left and right levels to match at the driver's seat to solve the 1st problem? And then we use the equalizer split apart. We EQ the left side differently than the right side to solve the 2nd problem. And then when we get to the 3rd problem, that the speakers are different distances, we ignore it and let the Bose processing work for us. Well, in my testing, it turned out we get a pretty darn good 1-seat car. It probably still has some improved vocals for the passenger, but I got very good 1-seat stereo just by taking care of the first 2 problems of stereo, level and EQ, matching them from the driver's seat left and right. Now, if your plan here was to do a total reference level system, like if you're using Thesis speaker components and Thesis electronics, I probably wouldn't use this approach. I would probably use an external preamp, or I would use a bit virtuoso and undo all that phase processing using dephase in the front end of the virtuoso. But for this level of OEM upgrade, I would have no problem at all delivering this kind of stereo presentation day in and day out.
Whoa, I'm very happy to hear that it works so well in this case. But what if you wanted a three-way system?
Well, what I would do then is, let's see here, I would use an AP2 as a mid-range, and then I would put a tweeter in the pillar. Now, I would only do that if I was going to set it up as a one-seat car. I think putting tweeters in the pillar really doesn't work for two-seat cars unless you have an up mixer, because the near tweeter drowns out the far tweeter. It's too easy to notice where it is. So in other cars besides this truck, I would use the AP2 together with the APK 165 component set that we just talked about a couple of minutes ago. And then I would have a three-way front stage, and I could power that three-way front stage active off the front of the Forza, 85 watts by 6 channels.
Ooh. And that leaves 2 channels for the rear speakers, and you could use the channel 9 to drive the subwoofer amp.
Luca, I have a question.
Is there, you want to ask me why we are doing rear speakers?
No, I mean, yes, I always want to ask that question. But this question is, what sub amp are you talking about?
Oh, that's a good question. Let's see. We've had the AP1D for some time now, and it's the companion, the perfect companion mono amp to the AP 8.9 bit. And it matches the 8.9 bit design and footprint. It fits perfectly the Prima tower kit, and it has 310 watts RMS into 4 ohms and 540 watts into 2 ohms.
But that's not the amp you meant, is it?
No, it isn't. And I'm happy to present you the new APF1D. And this is the companion mono amp to the Forza 8.9 bit. It matches the Forza 8, the F8.9 design and footprint, stable to 1 ohm and with much more power.
How much more power?
So 500 watts into 4 ohms, 800 watts into 2 ohms, and 1000 watts RMS into 1 ohm. Using an APF 8.9 bit into 4 ohms and an APF1D into 2 ohms, you get 1660 watts of RMS continuous power.
Wow. So you can do bigger bass systems with Audison, not maybe huge bass systems, but now you can do 2 10s with 800 watts. You could do 4 10s and 1000 watts. You could do 4 8s and 1000 watts. Yeah.
And because the Prima subwoofers are all flat subs and they need very little internal airspace, you don't need much room for doing it. Audison is well known for sound quality, and the APF1D uses high quality components such as audio grade capacitors. It is very powerful and great sounding monoblock amplifier.
Well, that's a really useful amplifier. When does it ship?
Oh, it is actually shipping now. The first lot of production, it is on its way to our domestic market, Car Audio Specialist.
Really? Are you serious?
Yes, strangely, for one time I am serious. But let me show you this. This amp is real.
Wow. So there you have it, folks. It's a real amplifier. And if you go to the website, you can learn even more about it.
Sure. Now, we can say there is a Forza family, right? An 8-channel amplifier with BDSP, a new powerful mono amp to match it, speakers and subs for advanced system design. It fits, it sounds great, it's flexible, and it's powerful.
Now, I've installed Forza amplifiers and I've installed these speaker components, and I'm really impressed with them. I wouldn't hesitate to do those in my business every day.
Okay. Also in this episode, we covered a lot of ground. I think it is time now for the question and answer section. And please use the Q&A function at the bottom of your screen. Sorry to insist on this point, but do not use the chat. The chat is erased after the session while the Q&A remains in our files. So let's see. Billy is asking if there's any problem with factory Bluetooth or door chimes.
The best answer I can say there is that if you use the right channels, that there's no problem with factory Bluetooth. Sometimes the factory Bluetooth comes out the center speaker, and if you haven't done your testing at the beginning, you might miss that fact, but there's generally no problem with factory Bluetooth. As far as door chimes, the worst thing I've ever had to do with door chimes, if they did get really loud, is I will take one of the parametric EQ bands and I will turn the Q up as high as I can and set it right on top of that door chime sound. And that is the worst thing I've ever had to do to take care of door chimes.
Yes. Now, Ron Scott is saying, I missed the other episodes. Were they recorded so I can watch them? And I can answer this. Of course, Ron, it is on our website in the same page where you have been registering for this one. So the previous episode, instead of register, they show replay, and you can watch them all the time you want. And no need the subscription as for Netflix or other streaming platform, right? Johnny Doss is asking, will there be a 6.5 coax for the Forza power? Well,
that's an interesting question, because I've been doing this a long time, and back when I started, almost no cars had tweeter provisions. Nowadays, so many cars have a tweeter grill of some kind that I think the thinking at this moment is that most cars will be taken care of by the separate component set, especially when you have all those different ways to install the tweeter.
And Olga from Germany, hi Olga, how are you? Will there be more amplifier model for the Forza line? And I think by the next year, you're gonna be having good surprise on the Forza line side. So yes,
yeah,
but
you give him a new amplifier, he wants another one right away.
You see, it's like kids with candies, right? Cody is asking, I very possibly missed this, but with Maestro, would you be able to retain the center channel in cars track like Ford F-150 2015 and newer?
So in general, when you have a car that has a center channel that is derived in the amplifier, this is true whether that center channel is a upmix center channel or a mono center channel or one of the other flavors we talked about back in episode 2. So whenever you use an external preamp and get in front of that amplifier, you eliminate whatever processing created that. Now, in my experience, the center channel in those Fords is not created by a true upmixer, so it's not that valuable. And even if I was upgrading without a Maestro, I would disconnect that center channel. So I don't think there's any value in retaining it, but Maestro is not intended to retain factory processing. It's intended to replace factory processing, and that includes whatever created that center channel.
Okay. Thanks, Cody, for your question. And then Olga again is saying, and be careful here, by the way, the APF1D is working really great. And just to let you know, Olga is one German dealer. And when we talk about domestic markets, we intend Germany and Italy because we serve Germany directly. And Olga is one of the lucky guys received this amplifier, and glad to hear that it's working really great. Thank you, Olga. And then we have Sean. Yes.
So you were working on a Volvo S90 and the chimes were very loud and the vehicle didn't let you adjust them. And the only way that you could do it was to back down on the processor input. I don't know if this is what the engineers were thinking, but that is one of the values of having the higher Q value in the Forza, is to use it in that sort of application. That's how I have used it.
And Fabian is asking you probably about the Sierra system. Do you have any graphics of the final output after you did the equalization?
I don't have them handy, but we can touch base after the webinar and I can see what I can come up with for you. Are you asking about the RTA curve or the settings of my equalizer?
So Sean is thanking you.
So Sean, I guess what I was trying to suggest is that you use your graphic equalizer, and yes, I think you got it. I see there that you got what I was talking about.
Now, Drozwiza from Israel. How are you, Dror? Long time not seeing you, my friend. And he's saying, what about cars with ANC, active noise cancellation? Any solution?
We did talk about this more in episode 1, right?
Episode 1. I think we did a little remark on episode 2 as well. So,
but to answer your question, basically, that is something you have to defeat external to the amplifier process. If there's a Maestro preamp, and I don't know what market you're in, so Maestro doesn't serve all markets internationally, but one way to defeat that is with an external preamp. But after that, it varies from car to car, and you do need to have access to wiring diagrams to figure out which wire to disconnect to get that result.
Sure. Thank you, Dror, for your question. And
okay. I might have saved the RTA graphics, Fabian. I'm really bad at saving those because those are always at the end of the day. And so I am very bad at saving the RTA graphics, but I will see if I did.
Okay. Okay. So guys,
but it looked really good. It looked like my target curve. I didn't have any problems there.
Let's go on. Let's go on with questions. We're leaving soon. So take the advantage of having, of course, Ken live for you. I'm just reading the questions. Happy to.
I thought I was going to have more questions, I got to tell you.
Yeah, probably they're rewinding. So let's go on and close this question and answer. And for those who would like to talk with us in the
there are a couple of in the chat that I will try to mention.
Okay.
One is, what if you have RCA? And I'm not sure if I know when that question was, but the Forza does have dedicated RCA inputs. So while the Prima was intended primarily for OEM integration, the Forza is equally intended for use with aftermarket head units. And then Helmut Wolfler, why do you have so difficult frequency problems on better search by phase problems? And I think there's probably an English translation challenge there, but I think if we're going to talk in depth about frequency and phase, we have to go to the bar, and it's only 11 o'clock in the morning here on the west coast of the US, so we cannot go to the bar yet. It is too early. Keith, from you, we will always take more questions. Okay.
So, I think Helmut again is asking, have you a solution about fast input switch for warning tones like Scania? Was it the one that you read? Scania is
no, that's a different one. And I think I know what he is referring to, and it's a vehicle specific sort of reaction where you try to cut out the warning tones. And I think it's a vehicle to vehicle solution. So I would look for third-party suppliers that have solutions for that, because I don't think it's an amplifier thing yet. Fabian is asking about the max voltage outputs of the Bit 1, and I don't know that because I haven't used a Bit 1 since the Virtuoso came out and the Nove came out. So I'll have to ask Luca for that. Okay, Fabian, we get back to you on this. You're on the Q&A, and then I think you can easily find it anyway in the test sheet in audison.com, but the question will stay here, and we probably send you within the soonest test sheet of the Bit 1 all itself. Oh, so Helmut is asking about vehicles that have a dual voice coil door speaker and one channel. Scania is a truck brand here in Europe. Yeah. Well. So depending on the system you're doing, you can have some success there, summing it in as like a front high and front low and let it be summed back in. And then you just may have to equalize it after that. But you could treat it like front high and front low and run it into the channel and let it sum it back together. Keith is asking about Italian products being shipped to this part of the world. And I think we'd probably have to check with Massimo, who's not on this call, who is the international sales manager for North America, because I don't know the situation in Montreal. Last I heard, they had just received a shipment, but that was weeks ago. Yeah, well, I probably inform a little bit more about this, and there's been a lot of raise in the demand and request of the Italian products. Thanks God, I would say.
And I think it's just a bit of patience, but we kind of provide all the requests we had, Kit. But if anything specific, I think you can refer to Massimo, to your distributor. And
Keith, the real question is, how many would you like?
well, yeah. So here we sell only by container, you know.
So are there any changes to Voce series in the near future? They don't tell me anything. I don't know.
Probably, I don't know. Let's see.
Keith wants all of them. So, hey, I think your rep is on this call, Keith. So he'll be calling you when we're done.
Okay. I can do the same as well. Eh? Let's call it later on. And okay, guys, it's very nice seeing you so active after a long session. Thanks for your participation. Now, yes, we're gonna be seeing you again in 2 weeks' time. Stay connected. The last 2 episodes are very important. But meanwhile, if you have any further question for me or Ken, you can write at support@electromedia.it, referring that you were attending the webinar, episode number 4, and which is the question you would like to share with us. But now, let's see, before leaving you, let me tell you what it's going to be on the next episode. We're going to share with you a complete overview of the Audison DSP line. And we're going to be helping you in choosing the best standalone DSP for your needs. And we're going to unveiling special function and tricks to optimize your use. So it's time to go. Thanks of all of you for being with us today.
Thanks for coming. See you in 2 weeks.
See you guys. Stay tuned. See you again.